Okay, number 218. This is a very hard problem. There are 30 decimals, and we're basically told if the if the tens digit is like this, if it's odd, then you round down, and if it's even, like it is here, then you round up. So this 1.3 would become 1.0, this 1.4 will become 2.0. So the question is asking us what are the possible values for e minus s? That's basically the estimate minus the actual. So they gave us three different numbers, and our job is to figure out which of those three are possible values of the estimate minus the actual. Well, to do that, we need to find what are the range of possible values and then see which of those three fit in that range. So in order to do that, we have to examine the different use cases, the maximum, and then also the minimum. So let's say we split this up, and we have the estimate on one side, and then the actual on the other side. So this is the same for the minimum. So what are the extreme cases for this? Say for example you have a number like 1.001. This is an even tenth digit, so this would naturally round up. And again, we're told 1/3 of these 30 positive decimals are even, so we have 10 of these guys. So 10 of them are like this, and they round up. Another extreme is if you have, well, this is for even. For odd, the remaining 20, the extreme is 1.999, and that's if you round down. Well, in this case, these are actuals. The result here, you actually get 10 times effectively 1, so that gets you basically 10. 20 times effectively 2, that gets you not 20, but actually 40. Well, since you round this up, this 1.001 would become 2, so this estimate would give you actually 10 times 20, which is 10 times 2, which is 20. The estimate here would basically be 20 times 1, which is 20. So the estimate in both cases with these actual numbers gets you 20. And let me just write that out. That's basically coming from 10 times 1, and this is basically coming from 20 times 1. Oh, this is 10 times 2. Right, so this rounds up, that becomes 10 times 2. Now this is the maximum extreme for even digits in the tenths, and this one's for odd. We have to do the same for the minimum. Well, the minimum, let's say we have a number like, well, when do you get the least difference? And that's basically when you're so close to 2, but you still satisfy the even requirement. So 9 obviously is odd. The highest even number is 8. But then when you round it up to 9, you get the least benefit when you get something like this, 1.899. So we have 10 of these guys because it's even, and then we have 20 of, what's the odd scenario where you have a number and you get the least benefit? Well, that's least benefit is basically 1.1 000. So that's when you get the least benefit. In this case, you would round, since this is even, you would round up. So you only move up by a little bit. And then in this case, this is odd, so you round that down. So in terms of estimates, this effectively becomes, a 10 times a 2, and this becomes effectively a 20 times a 1. Again, this is 20, and this is 20. In terms of actual, this is basically 1.189. I mean, that's effectively 1.9 times 10, which is 19. And then this effectively is 22. So this one is even, and this is odd. Alright, so this entire row is odd, this is even. So if our job were to pick from these four extremes, these are the four extremes, and you want to combine them in such a way that the difference is maximal and then the difference is minimal, then how would you combine these to get that difference? Let's say that difference is e minus a, estimate minus the actual. So we can create a column here called e minus a. So what is the difference? Well, the difference between the 20 and the 10 gets us a positive difference of 10. 20 and 40 gets us a difference of minus 20. This 20 and this 19 is basically a difference of plus 1. This 20 and this 22 is a difference of minus 2. Again, we're looking at this column. These are the actual, values when you multiply 10 times these numbers and then 20 times these numbers for the odd ones. So these are the four extreme situations. Your job, of course, is to pick an even set and then an odd set, right? So which even set and which odd set would you combine to maximize the difference? Well, to maximize the difference, you want the most positive difference. The most positive difference for even is this plus 10. All right, which odd set, this one, this one, or this one, which set, meaning do we want this one or this one? Given that we've chosen plus 10, you want to combine that plus 10 even with one of these odd rows. Which odd row do you want? You want the one that's more positive. Well, that's basically the same as which one's less negative, which is minus 2. So we want to combine this plus 10 with this minus 2, and then you'll get the maximum difference is actually the plus 10 minus the 2 equals plus 8. So that's the maximum difference. The most extreme in terms of the minimum difference, well, that's basically the minus 20 here. If you picked this even and then this odd, if you pick this even and then this odd, so that's basically the minus 20 combined with the plus 1 row. That's basically the this row combined with this row, you get minus 20 plus 1 equals minus 19. So combining everything together, your range is minus 19 to plus 8. So basically everything between this and plus 8, right? So this is basically, the range of possible e minus a values, right? The range of e minus a values are in here in this range. So you have to go through all three possible values. You're given three possible values: minus 16, 6, and 10. Minus 16 works, 6 works, but 10 is outside of this range. So that means statements 1 and 2 are good, but not the other guys. So that means the answer we want is answer choice B, 1 and 2 only. Okay, so let's look at concepts. So you're basically asked, what's the difference between the estimate and the actual? The estimate is defined as, if depending on the tens digit. If it's even, you round up. If it's odd, you round down. So the way we did this was we tried to challenge that. We tried to find extreme examples of when the estimate is completely off from the actual. And it's most completely off when you have a situation like this, 1.0 rounding up to 2, and then 1.999 rounding down to 1. So these are the extreme situations. One is for even, and one is for odd in the tens digit. So those were the extreme situations. And then we also wanted to compare that to the extreme situations to the other way, meaning where the estimate minus the actual, the difference is actually very little, the least you can get. So the least is when you have 1.8, which is going to round up to 2, but to minimize that effect you want to get it as close as possible. So that's basically 1.9. So 1.8999. In this situation, you round up. But it's not, this is definitely the opposite of 1.0 rounding up. So what about the other way for odd? Well, odd, it's basically the lowest odd number is 1.1, then that rounds down to 1. So these are the 4 example situations, and then for each of these we basically processed them and found what's the actual. Well, the actual, when you actually round it up or down, these are the values. Again, for the even ones, you multiply them by 10, because we're told that 1/3 of the 30 decimals are even, and then the remaining 20 are odd, so we multiply the odd ones by 20. And so in both cases, we get a list of actual values, so 10, 40, 19, and 22. And then for estimates, you find the values 20, 20, 20, and 20. This is just a sample situation. Then your job is to find, well, what are the range of possible values for E minus A? Well, the range is basically when you can maximize the difference between this E minus A. So to do that, we basically created a column called E minus A, and we calculated what is the difference. You know, we marked the difference as plus, keeping track of plus and minuses. If actual is 40 and the estimate is 20, well, the 20 minus the 40 gives you minus 20. So we added them all up and came up, some of them with positive values, some of them with negative values, and then found that if you combined an even line with an odd line, the maximum value would be a positive 8. And then the minimum, the most negative value, would be a minus 19. So the range is between minus 19 and positive 8. So these are the acceptable values. They gave you 1, 2, and 3, Roman numerals 1, 2, and 3. And the values for those were minus 16, which is good, 6, which is good, and then 10, which is no good. So the first 2 were good, the last one's no good. That's why answer choice B is the answer. So as a recap, we basically found this question, and it asked us what is the difference between estimate and actual. We created a chart, estimate and actual. We picked 4 values that we could test that show the extreme on one end and also the minimum, and then we also calculated the difference between the E minus A for each of these situations. Then we combined an even line with an odd line to find out what the upper end of the range is, and then the lower end of the range. And so this range is basically the acceptable values that you can get. And it turns out that the answer is just the first 2 that are provided, and that's answer choice B.